Welcome to iCode. In this video, I will show you how to create a doubly linked list, right? You can see here the appearance of a doubly linked list, right? Okay. Doubly linked list is a variation of linked list in which navigation is possible in both ways, right? It means either forward and backward, right? It means we can traverse along the list from head node to tail node as well as from tail node to head node, right? Now this is the appearance of a node which is using in a doubly linked list, right? Okay, there are three parts of each node: two pointers, previous and next, as well as a data part, right? This 100 indicates the memory address of the node. Okay, so this next pointer is used to store the memory address of the next node, and this previous pointer is used to store the memory address of the previous node, right? Here you can see a sample doubly linked list, right? You can see here there are two additional references or pointers to access the list called head and tail. So identify clearly the difference between head reference and head node. This 100 node is a head node and this head is a head reference, right? We use reference to store the memory address of a node, right? But okay, when we consider a node, it takes a node exists, memory address as well as a data part, right? Okay, this 100, 200 and 300 are the memory addresses of each node respectively, and suppose this head reference, it is storing the memory address of the first node, that is head node 100. And now consider this head node, right, which is the 100 node. The previous node of the 100 node is null, and the next node of the 100 node is 200, that is this 200 node. Okay, now look at this 200 node. The previous node of the 200 node is 100, and the next node of the 200 node is 300. Likewise, we can construct a doubly linked list. Okay, and the last node, this is 300 node. There are no any next node, that's why this is null, and the previous node of this 300 node is 200, right? That is this second node. Okay, now let's see how to construct this kind of linked list using Java. Okay, this is my Eclipse IDE. I'm going to create a program using this Eclipse IDE. Here you can see I have created a package under data structure, right, called doubly linked list. Now I am going to create a new class. Okay, here. Okay, this is our node class, right? Okay, this is our node class. Okay, now suppose we want to create a doubly linked list to store some integers, right? Therefore I use an attribute called value, that is integer, type integer. And as I mentioned previously, each node contains three parts, right? Data part and two pointers, right? Okay, let's create two pointers called next and previous. Okay, now I'm going to generate the constructor. Okay, now this is my constructor. We pass some integer value and set it to the attribute, right? And at the beginning, we can set these two references to null, right? It means when we create a node at the beginning, two pointers are set to null. It means no any previous node or no any next node, right? Okay, now save it. Okay, now I'm going to create another class to create a doubly linked list, right, called doubly linked list. Okay, this is my doubly linked list class. In this class, as I mentioned previously, we need more two references to access the list called head and tail, right? Now I'm create that two references here. Okay, now this is my constructor. We don't need to pass any parameters here, right? Only thing we do is we set both references to null, right? It means at the beginning no any nodes, right? No any nodes in the list. Okay, now save it. Okay, now I'm going to implement the function to create the list. Let's say add node. Okay, here we need some parameter, right? Type int, because we are going to create a list to store integers, right? For therefore, to construct a node, we need some value. We need some integer value. Okay. Now, first of all, I am creating a new node. Okay. Okay, this is my new node, right? We can pass the value here, and we can create a new node, right? Okay. Then, okay, so far we have these two references, right? Head and tail, and both references are set to null. Okay, now suppose this is our first node, right? The value of the node is 10 and previous, right? As I mentioned previously, previous node and the next node are null, right? Here you can see when we create a node, we set both both pointers to null, right? Okay. Now to add this new node to the list, what we have to do is we need to set this both reference to this node, right? It means we should point this two reference to this new node, right? In order to do that, we can store here the memory address of the new node, that is 100, and also here we can store the memory address of the new node, that is 100, right? Now we have two new links like this. Okay. Okay, now both references are pointing to the first node, right? Now, okay, now let's move back to our function, right? Okay, now first check whether the list is empty or not. Okay, we can accomplish the task by using simple if condition, right? Okay, if this dot head equal to null mean if head reference equal to null mean the list is empty, right? So now we can create about two links, right? Okay, now you can see here, now we have pointed to both reference to the new node. Okay, else mean what we have to do if the second node come to the picture, right? Okay, now suppose this 200 node is the second node, and now we are going to add this 200 node to the list, right? Okay, now first what we have to do is we have to set this 200 node is the next node of this 100 node, right? In order to do that, we can change this memory address to 200, right? It means now we have a new link like this. Okay, then what we have to do is we set the previous node of this 200 node is the 100 node, right? In order to do that, we change this memory address to 100, right? Now we have another link like this. Okay, finally we have to change the tail reference, because the tail reference is always pointing to the last node, right? Now the last node is 200 node, which is the newly added node. Okay, in order to do that, we can change this memory address to 200, right? So it means this link doesn't exist anymore, and we have a new link like this, right? Now this is the appearance of our linked list. Okay, now there are two nodes in the linked list. Now we are going to implement the procedure in the else part, right? Else. So now suppose now we are going to add another node to the list, and now head reference is not equal to null. It means at least one node in the list, right? Okay, don't forget to order of the links which we have created, right? First this link, and then second this link, and finally we change the tail reference. Okay. Okay, now we added a new node to the list, right? Okay, now I'm going to add another node to the list. Then you can clearly identify the step by step what happens, how it works, right? Okay, now this is another node. This is new node. This is a new node, right? The memory address of the node is 300 and the previous and next pointers are null. Okay, now we are going to add this node to the list, right? Okay, now obviously we can use this else part because in this moment the head reference is not equal to null. Okay, now according to this line, okay, tail dot next equal to new node means, okay, it means now tail is pointing to now tail reference pointing to this 200 node, right? Tail next equal to new node, right? You can see here tail next equal to new node. It means now this memory address will change as 300. Okay, now we have another new link like this. Okay, then the second line, look at carefully the second line, right? It means it says new node dot previous equal to tail, right? It means this is the new node, this is the previous point of the new node, it is equal to tail means this is changed to 200, right? It means we have another new link like this. Okay, and finally this dot tail equal to new node. Now we are going to update the tail reference. It is equal to new node means now we have a new link like this. Okay, now I think you can understand the concept clearly. You can add more nodes, but the procedure is same. Okay, now we have created the add function. Okay, now I am going to create another function to traverse the list, right? As I mentioned previously, a doubly linked list is a variation of linked list in which navigation is possible in both ways, right? So first I'm going to create a function to print the list forward. It means we use this function to print the details of the list to from head node to tail node, right? Okay, I uploaded the video previously to explain how to search a node in single linked list, right? In that video we discussed details. We discussed the concept of this print method and search method in detail. You can check out that video. I will provide a link in the description, then you can identify clearly the concept how this works, right? Okay, this is the print forward function, right? You can see here I have created a temporary reference and set it to the head node, right? In the same way, now I'm going to create a function to print the details or print the data from tail node to head node, right? Because we can traverse along the doubly linked list from both sides, right? Okay, I call it as print backward, right? The other things are same as print forward method. The only difference is at the beginning we set this temp reference to the tail node, right? Because now we are going to start from the tail node, and we should change this as now the temp reference is moving to previous node, right? That is the only difference, right? Okay, now I'm going to create another class called driver. Okay, in the driver class, first of all, I will create an object, right? I will create an object, doubly linked list class. Okay, as now I'm going to add some values to the list. Okay, in order to do that, we can call the add function here. Okay, I'm passing some values. Okay, now you can see I have added 5 elements or 5 values to the list, right? Now let's check the output, right? Okay, first I will print the details in forward manner, right? That is start from the head node and end with the tail node, right? Okay, in order to get the forward result, I have called the print forward function here. Now let's check the output. Okay, let's remove this new line and I will add a space here, right? After each element, I will add a space, right? Okay, now let's check the output. Okay, I will add another new line here, then you can clearly identify 2 results, right? Okay, you can see here the first function, that is print forward function, gives the result as 10, 20, 30, 40, 50, and print backward function gives the result as 50, 40, 30, 20, 10. It means it print the details in backward manner, right? Okay, now you can clearly understand the doubly linked list works correctly. It means we can traverse along the list from both sides, right? Okay, in this way you can create a doubly linked list. Okay, if you got some knowledge from these videos, don't forget to subscribe, and the next video I will show you how to insert a new node to the doubly linked list, right? See you in next video. Thanks for watching.